So we take a look at 9. We're going to use this equation to answer the following. We're going to find the turning point, and the turning point is negative 6, 4. Again, this changes, that stays the same. It is a max. The equation of the axis to symmetry is just x equals negative 6. So whatever the x value of your vertex is. The y-intercept, what you can do to get your y-intercept is just graph it in Desmos or look at the table or plug 0 in for x. So I'll plug 0 in for x just to show you. So you can always plug 0 in for x to get the y-intercept, and you end up getting negative 24. This becomes negative 30. This becomes negative 36 plus 4. Oh, sorry. Good thing I wrote that down. Negative 32. So that's our y-intercept, negative 32. In Desmos, you can just graph this. Negative x plus 6 squared plus 4. And one, it checks your turning point, negative 6, 4, that matches. It also shows you that, oh, it's a maximum because it's opening down. It tells you what your roots are. And then if we keep going, there we go. There's our y-intercept. It matches. Negative 32. Okay. So we go back. The domain is always, always, always negative infinity to positive infinity. Your range, you can get the range by looking at the graph. So we look at the graph, it's opening down, meaning the bottom of the graph is going towards negative infinity, and the top of the graph is the y value of your turning point, which is 4. So the range is going from negative infinity to 4. 4 is included in the graph, so we put a bracket around it. Again, you can get the zeros from looking here. Just click the x-intercepts, so negative 8 and negative 4. So when we graph it here, I'm just going to graph the turning point, which is negative 6, 4, and then the zeros. And there we go. We take a look at number 10. The turning point is just negative 4, negative 4. Again, the x value changes, that stays the same. There's no minus sign out in front, so that means it's a min. It's opening upwards. The axis to symmetry is just x equals negative 4. It's the number, the x value of your turning point. The y-intercept, you can find that algebraically by just plugging 0 in for x and simplifying. So we get 4 squared minus 4. That gives us 16 minus 4, which gives us 12. So our y-intercept is 0, 12. The domain is always negative infinity to positive infinity. The range, we're going to graph it to get the range, and that will also tell us what our zeros are, and we can also check our answer. So I'm going to graph y equals x plus 4 squared minus 4. So x plus 4 squared minus 4. So our turning point looks good, negative 4, negative 4. Our zeros are negative 6 and negative 2, so I'm going to write that down. Negative 6, negative 2. And our range goes from bottom to top. So the lowest our graph goes is the y value of our turning point, which is negative 4, and it's going all the way up towards infinity. So our range is from negative 4 to infinity. When we graph it, it looks like this. We go to our turning point, negative 4, negative 4. And graph our roots, negative 6, negative 2, and connect. It's a min, our turning point matches. Again, your axis to symmetry is just that imaginary line that goes right down the middle of your vertex. And if you also want to make sure you have the right axis of symmetry, graph it. You can say x equals -4, and it should go right through your, vertically through your vertex. Last one here for number 11. Again, the turning point is -4, 2. Again, this changes signs, the 2 stays the same. There's a negative out in front, so that means it's a max, it's opening down. The equation for the axis of symmetry is just x equals the x value of your vertex, -4. The y-intercept, again, you can just plug 0 in for x. So y is equal to -1/2. 0 plus 4 squared is just 16. -1/2 times 16 is -8, plus 2 gives us -6. So our y-intercept is just 0, -6. Again, our domain is always -infinity to positive infinity, and I think graphing it helps with the range. So let's go ahead and graph it. We have -1/2 x times x plus 4 plus 2. Oh, I forgot to square. That's important. Squared. So just check kind of everything. Our vertex matches what we wrote. Our roots are -6 and -2, so I'm going to write that down. And then our range goes from lowest is -infinity because it's opening down. And the highest it goes is always the y value of your vertex, so 2. So our range is from -infinity to 2. When we graph it, again, it looks like this. We just plot our vertex and then our roots. And it looks like that when we graph it. You can also check your y-intercept. We said our y-intercept was 0, -6. And when I go to Desmos, our y-intercept is 0, -6.